Hey folks, thought I'd do something a bit different this time. Today this video is going to talk about the ZeroLogon vulnerability. Well, the video is not going to talk about it, I'm going to talk about it. ZeroLogon, tracked as CVE-2020-1472, is an authentication bypass vulnerability in the NetLogon remote protocol, a remote procedure call interface that Windows uses to authenticate users and computers on domain-based networks. It was designed for specific tasks such as maintaining relationships between members of domains and the domain controller, or DC, or between multiple domain controllers across one or multiple domains, and replicating the domain controller database. One of NetLogon's features is that it allows computers to authenticate to the DC and update their password in the Active Directory, and it's this particular feature that makes the ZeroLogon flaw very dangerous. In particular, the vulnerability allows an attacker to impersonate any computer to the domain controller and change their password, including the password of the domain controller itself. This results in the attacker gaining administrative access and taking full control of the DC and therefore the network. ZeroLogon is a privilege escalation vulnerability and is rated as critical by Microsoft, even though the company said in the original advisory that exploitation was less likely. It is not a vulnerability that allows attackers to break into Windows networks, but it is highly valuable as a second stage exploit for lateral movement. Researchers from Dutch security firm Secura, who found this vulnerability, released a white paper that explains in detail why the flaw exists and how it works. MS NetLogin Remote Protocols Handshake and authentication involves the use of AES CFB8, 8-bit cipher feedback mode. This is a more obscure variant of the AES block cipher that is designed to work with blocks of 8 bytes of input instead of the regular 16 bytes. So how does NetLogon actually work? Well, a client computer that wants to communicate with a NetLogon server, such as a Windows domain controller, starts by sending 8 random bytes, what's often called a nonce, short for number used once, to the server. The server replies with 8 random bytes of its own, as shown here. Tom Tavert of Secura explains in a white paper, in order to be able to encrypt the initial bytes of a message, an initialization vector must be specified to bootstrap the encryption process. This IV value must be unique and randomly generated for each separate plaintext that is encrypted with the same key. The compute NetLogon credential function of the MS NRPC protocol, however, defines that this IV is fixed and should always consist of 16 0 bytes. This violates the requirements for using AES CFB8 securely. Its security properties only hold when IVs are random. Tavert figured out that because of this implementation error for 1 in 256 keys, applying AES CFB8 encryption to an all-0 plaintext will result in an all-0 ciphertext. In the context of MS NRPC, the attacker impersonating a client can send a challenge during the handshake made up of 8 bytes of zeros and keep retrying for 256 times until the server will accept it, bypassing authentication. This is a simplification of the whole process, which is detailed in the white paper. Because the goal of a handshake and a key exchange protocol is to establish a shared secret between two parties that is used to secure the connection without actually exposing passwords or secret keys before the communication channel is secure. So what does all of that mean? What does it actually look like when the process takes place? Well, let's find out, shall we? So, in order to test the feasibility of exploitation in the field, let's return to the vulnerable lab that I have. So I have already cloned a domain controller. I've cloned it from Zeus here, and the one underneath it is Zeus clone, just in case it goes pear-shaped and it breaks anything. So that's already taken place. Let's just start the actual process now. So starting again as always with an ARP scan, just identify the target, but I already know ahead of time what the target is because I've logged onto the box and got the address. But we can see it here as .18. So all I need to do now is actually perform an nmap scan just so I can confirm the net BIOS name of the machine. So let's just go ahead and do that now. So with nmap scan complete, we get the fully qualified domain name and we also get the net BIOS name. Now for the proof of concept scripts that we have, we only need the net BIOS name for this script to work. So for the script to run, we just need the DC name and the DC IP. So let's go ahead and enter those details and see what happens. So that looks like a success. So this proof of concept script here basically just checks, it doesn't do any compromise, it's just checking to see if the server is vulnerable, and it's confirmed that it is, which is good. So now let's move on to the other proof of concept script we have, which should set the administrator password as blank. The syntax is the same as the last one, we just need the DC name and the DC IP. So let's go ahead and enter that and run the script and see what happens. Yes, so that looks like that's worked as well. So it should have set the admin password to blank. Let's run the secret dump script and unpack it and see what happens. So let's just press enter. Oh, there we go. That's looking fantastic. So as we can see, it appears to have dumped all the hashed credentials. The first one on the list there doesn't look like a standard name. Now, I know what that account is, but for the benefits of the video, let's just see what we can actually do with this password. So let's go over and fire up Metasploit and see what happens. Now that's disappointing. There's got to be something wrong here, because I would have expected that to have worked. And yep, I think there's these extra characters here at the end of the password. Rookie mistake. Right, let's give it another go and see what happens. Yep, that's immediately looking better. This is looking very promising indeed. Hopefully the shell should come back. Oh, there we go, a interpreter shell. Bingo! Right, let's just drop here into a Windows shell and see if we can get a list of the domain admin accounts on this domain. So we just enter the command netgroup domain admins, and yep, you can see there straight away that the Smoke Dog account was actually a domain admin. What a bit of luck that was, eh? So rather than take over that account, let's create an account of our own and make that domain administrator. As a domain admin, we should have the rights to do that. So let's just add the account jock to the domain admins and see what happens. Oh, for God's sake. Getting ahead of myself here. So before I can add the jock account to the domain admins, I actually need to create the jock account. So let's just do that here and use a password that you wouldn't find in the RockU list. And let's just add that in just now and get that confirmed. Should be good to go. Yep, there we go. And now let's just add it into the domain admin group and we should be all set. Yep, there we have confirmation. Jock is now a domain admin. Look out, here I come. Right, let's just go ahead and RDP onto the box with the Jock account that we've created, and as you can see, takes you straight in. So this is the domain controller for the Olympus lab, and we're logged on as the domain admin. So as you can see, now we have complete unrestricted access to the Olympus domain with the domain admin account that we've created here. And just to confirm, there it is, Jock domain admin. So that's it folks, that's using ZeroLogon proof of concept scripts. Hope this video was helpful, and I'd like to thank you all for watching. Ta-ta for now.